Hello everyone, welcome to Homework Hell. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using derivatives. So as per the problem, a farmer has 600 meter of fence and wants to enclose a rectangular field beside a river. Determine the dimensions of the fenced field in which the maximum area is enclosed. And as per the problem, fencing is required only on three sides, those that aren't next to the river. So the first step here is to draw a diagram for this problem, and the diagram will be a rectangle. Now here the rectangle has a fence, and the total length of the fence is 600 meters, and the fence is only required on three sides of that rectangle because there is a river along the fourth side. So the diagram of the rectangle will look something like this. So these three sides represent the fence that is used to make this rectangle. So let's assume the length of this rectangle is L and the width is W. So the sum of these three dimensions should be equal to 600. So that's our first equation. So W plus L plus W equals 600 meters. Now we can simplify this equation by combining the like terms on the left side. So W plus W is equal to 2W. So 2W plus L equals 600. So this is the equation we get from the given length of fence used to create this rectangle. Now we have to find the dimensions that maximize the area. So the next step is to write an equation for the area of this rectangle, and we know area of a rectangle is length times width. Now this area equation has two variables L and W, and we can isolate L from the length equation and do the substitution for L in the area equation. Now we want to isolate L because the coefficient of L in the length equation is 1, so it's easier to isolate L from this length equation. So we can move the 2W to the right side of the equation, and we get L equals 600 minus 2W. And now we can do the substitution for L in the area equation. So we get area equals, so instead of L, we write 600 minus 2W times W. Now we can distribute this W into the parentheses. So we get area equals 600W minus 2W squared. So this area equation has only one variable, W. Now we have to find the dimensions which maximize area. So for that, we have to find the W values for this area equation at which the tangent is horizontal, because the tangent is horizontal at peaks in the graph of the function. And the slope of the tangent is equivalent to the derivative of the function, in this case the area function. So the next step is to find the A prime. So now we have to find the derivative of this expression. So for 600W, the derivative will just be 600. And then for 2W squared, so 2 is the coefficient of the term, so it will stay as it is. And the derivative of W squared will be 2W. Now we can simplify this equation. So prime of A equals 600 minus 4W. Now in order to find the value of W at which the tangent is horizontal, we can sub in A prime as 0 and then solve for W. So now we have to isolate W in this equation. So we should add 4W to both sides. So the 4W's on the right side will cancel each other out. So we get 4W equals 600. And now we can isolate W by dividing both sides by 4. So the 4's on the left side will cancel each other out. And we got W equals, so 600 divided by 4 is equal to 150. And the unit of 150 will be meters. So this is the W value at which the tangent to this area function is horizontal. Now we also have to write the interval for W, which represents the possible values of W for this problem. So we know W represents width, and width cannot be 0 or less than 0 for this situation because this is a two-dimensional shape, and if the width becomes equal to 0, then this rectangle will become a straight line. So width has to be greater than 0, and as per the length equation, so 2W plus L is equal to 600. Now as the length decreases for this rectangle, the width will increase because 2W plus L is equal to 600. So the maximum possible value for W will be when L approaches 0. So if we sub in L as 0 in this length equation, then we will get, so I can show you the steps here. So 2W plus 0 equals 600. And if we solve this equation, so we get 2W equals 600 and then W equals 300. So that means the maximum possible value for W should be less than 300 because we get this 300 value at L equals 0, but L cannot be equal to 0 because then the rectangle will become a straight line. So we have to find the value of this area at 3 W values, at W equals 0, W equals 150 and W equals 300 to test where we get the maximum value of area. So let's start with W equals 0. So A at 0 will be equal to, so now we have to use the area function, which is 600 times 0, which is the value of W for this analysis, minus 2 times 0 squared. So this will be equal to just 0 because 600 times 0 is 0 and 2 times 0 square is 0. Now we can use the value of W we got, which is equal to 150. So the area will be equal to 600 times 150 minus 2 times 150 squared. Now we can solve this expression. 600 times 150 minus 2 times 150 square is equal to 45,000. And the unit will be meter square because the unit of the length is meter in this problem. Now we find the area when W is equal to 300. We do 600 times 300 minus 2 300 square. And the area when W is equal to 300 is equal to 0. So that means the maximum area value from these three values, three W values is this 45,000 meters squared. W equals 150. Now we have to determine the dimensions. So that means the width of the rectangle should be equal to 150 meter. Now we can find the value of L, and for that we can use this L equation in which we isolate L from the length equation. So L equals 600 minus 2 times 150. So we get L equals 600 minus 300, which is equal to L equals 300, and the unit is meters. So this is the length of the rectangle that will give us the maximum area. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand the given information. In this case, the rectangle we have to analyze has only three dimensions. So based on that, we write the equation for the length of the fencing used to create that rectangle, and then we write the area equation and do the substitution for the variable L, because it's easier to isolate L from the length of fence equation. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find the video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.